with radicals. This is not the problems that you're doing, but I'm just going to review something that you would have learned previous to coming to this class, maybe a couple years ago. I don't know if we reviewed this last year or not. So radicals are just square roots. I like saying the word rad instead of the square root of. All right, so we know on that first one, just because that's a common, what we could consider perfect square, the square root of 25 would be what? 5. Okay, so we already know the answer to that one. The ones that we're going to have aren't going to be perfect squares. So we need to remember how these are broken down. So this is why I have this up here. So we already know the answer is just going to be 5. Okay, but where that comes from is breaking a number down into prime numbers. Okay, so I know 5 can go into 25 5 times, right? And those are prime numbers because the only thing that can go into 5 is 1 and 5, right? You can't break those numbers down anymore. And so what you look for is you look for the pairs, okay? So I have a pair of 5s, so that means you take 1 out, okay? So the answer is just 5. There's no other numbers that were left because it was a perfect square, okay? And that's where that comes from, okay? Same thing on 64. We know 64 is perfect square, and it's what? 8. Okay, but if I didn't know that, I could start breaking this number down. So I'm going to start with 2, just because I know 2 can go into it. If you don't have all your perfect squares numbers, okay? So 2 can go into 6 3 times, and then 2 goes into 4 2 times. This is a prime number, but this one's not. Okay, so I can keep on breaking this down, and it doesn't matter where you start at, like what goes into that number. A lot of people, I just tell them to start with 2 and 3. Okay, so you don't have to think of big numbers. So if I went back to 2, 2 could go into 32 16 times. Okay, so that's a prime number, but 16 is not a prime number. I can still break down 16, okay, which can be 2 and 8. Okay, 8's not a perfect square, or isn't two prime numbers, so that would be 2 and 4. And then 4 is not a prime number. That breaks down into 2 and 2. Okay. Now, obviously, this is a long route, just making sure you know like where all this comes from. Okay, so we're looking for pairs, just like what we did here. Okay, so I'm just going to do it. So I have a pair here, so that means I'm going to take 1 out. I have another pair here, so I'm taking 1 out. And then my last pair, so I'm taking 1 out. So I took out 2, a 2, and a 2. So when you have multiple numbers that come out, and I'm doing this also because you'll have like a pair of 2s, a pair of 5s, and a pair of 7s. When you take them out, you multiply them, okay? So 2 times 2 would be 4, times 2 is 8, which we already know that the square root of 64 is. Okay, so whatever pairs you're taking out, you multiply. You won't always have the same numbers. Okay, so now variables. Variables are the same way when you break them down. This really means x times x, right? So that means I have a pair of them, so it comes out. So x to the second power is a perfect square. It's just x. Okay, so that's one way, which is easy when you have small numbers. But say you had a number like 22, x to the 22nd. You're not going to want to write out 22 x's and then circle to figure out how many that you would be able to take out. So the shortcut to this is we're always looking for 2 of something, right? When we're taking it out. Okay, so when you have exponents, if you just divide that number by 2, that tells you how many you can take out. Well, 2 divided by 2 is 1. Okay, so if you had x to the 22nd, like we just said, and you divided that by 2, then that means I would be taking out how many? 11. Okay. Hopefully that'll help simplify some of them. Okay, next set. Hopefully you kind of remember this. As usual, forget, but Geo's floodgates are open right now. All come rushing back. He's got paper. Okay, so again, long route, even though there's not that many, you could go x, 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 and say I have a pair, or we can divide by 2, okay? Yeah,
Are you recording this?
I am. Do you want me to pause it?
No, I'm just making sure.
Okay.
I forget, so I was like, I should remember.
Okay. Yeah, Gio asked me to record. Okay, so 3 divided by 2 means it can go in there once, so that means I can take 1 out, but there is 1 left over. Okay, and then so what that looked like if we were to write it out, right, there would be 3 of them. Okay, so I have a pair, so 1 comes out, but there's 1 left over that doesn't have a pair, so it stays underneath. Okay, so whatever you don't have a pair of is going to stay underneath. Okay, which now is going to lead us to numbers. Okay, so what can go into 125? 5. Okay, 5 can go into 125 how many times? 25. Okay, 5 is a prime number, but 25 is not. 25 I can break down into 5 and 5. Okay, so I'm looking for pairs. So it doesn't matter which one you're grouping, like you can group those 2 if you wanted to, or group these 2, okay? So I only have 1 pair that's coming out. What did I have left over that did not have a pair? 5, okay? So that's similar to this one where we had 2 x's, okay? So I take 1 out, but there was still 1 left over that didn't have another pair to put it with, so it stays there. Okay, just kind of building here. Okay, 88. What do you want to start with on that one? 8 and 11. Okay, so 8 and 11. 11's prime, so I don't have to break that one down any further, but 8 can go down further into 2 times 4, and then 4 could break down into 2 times 2. Okay, so we're only looking at the prime numbers and looking at the pairs. So I have a pair of 2's, right? So that's going to come out, but I didn't have another 2, and I didn't have another 11 to put together. Okay, so the 2 comes out, and then what's left over, we multiply together. It's the same as what you take out. You have multiple things that you take out, you multiply, whatever's left, you multiply. So 2 times 11 is going to leave it as 22. Okay, so the common mistake on this is which one do I write on the outside, which one do I leave on the inside? Okay, so we're going to tell a Gio story. So when Gio goes on a date, he leaves the house. Okay, so that means he's with somebody else, right? Okay, so if he has a date, he's going to leave the house. If he doesn't have a date, okay, he's all by himself, he has to stay inside the house. Okay, so if you have a date, that's the number you write on the outside, because there's 2 of you, right? I don't know. I think he stays home too. Okay. Yeah. Okay. Almost there. This is national. Okay, so the only reason why I'm bringing this up is you're going to have some that are going to have radicals with this, but we just remember what we do when we add and what we do when we multiply. Okay, so on G, we have 2x plus 2x. So when we're adding, can I combine those 2?
Yes.
Yes. When I do, what am I doing with the whole numbers? What am I doing with the exponents? Nothing. Okay, we don't add them. It's just saying what are our like terms. You can only combine the like terms. So these guys have like terms, but you don't do anything with the variables. Okay, you only add the ones that are like terms. So this is 4x, not 4x squared. Okay, so this is just trying to get back in what you do when you add and what you do when you subtract. So we only add the numbers in front. Okay, we good? Okay, the next one. What do I do with each? Nothing, right? Because they're not like terms, okay? I know they both have x's, but they don't have x, y, so you can't combine them. So this would just be your answer. You could not combine them. Okay, only that one. Okay, now switching away from adding, subtracting, and going to multiplication. Right. Multiply these guys, right? But then you add your exponents. So you're really taking these two and you're adding whatever the exponents happen to be. So this would be x to the second. Okay, so there's a difference between that one and that one, between g and I. What you do with adding and what you do with multiplying.
Wait, is this what we're actually doing? Is this a run over?
This is leading up to it. Now we are starting. Okay. Okay, so 63. This is the first problem. So obviously these notes will be worth significant points towards the lesson. A little bit longer. Okay, so 63. We have the square root of 300. Remember, it does not matter where you start. If you can think of a big number, you can start there. If you want to start small, you can start there. Okay, so I'm going to start with 3. Okay, so 3 goes into there 100 times. Okay, 3 is a prime number, 100 is not. I could do 4 and 25, or I could do 10 and 10. I'm going to go with 10 and 10 because I can go ahead and stop here, right? Because I already have a pair. Okay, if you don't catch that, then you can keep on going. And go 2 and 5, and 2 and 5. Okay? All right, I have a pair of 2s. Okay, so I'm taking 1 out. And I have a pair of 5s. So I'm taking 1 out. So I'm taking out a 2 and I'm taking out a 5. What did we say we do with those numbers? Multiply them together. So 2 times 5 was 10. And that's where I was saying that just takes you back to that if you know that. If you don't, you're still going to get the same answer. Okay, so 10 comes out. I got a date. Who had to stay at home besides Gio? 3. Okay, there's your answer. Okay, so if you catch it, you get to stop early. If you don't catch it, you're still going to get to the same answer. And even if I decided not, you don't need to write this next one. If I decided to break this down and I went 30 times 10, I would get 2 and 5, and then 3 and 10, and another 2 and 5. I'm still going to get to the same spot, okay, where I have a pair of 2s and a pair of 5s. It doesn't matter how you break these down. Okay, yes?
So with the 30 and 10 right there, could you just combine like the broken down 30, like the 10, could you combine those 10s?
Yes. Yeah, maybe catch it. Yeah. So again, so whatever you're dividing into there, as long as you are multiplying and dividing right, you're going to get to the same answer. Okay, 61. Okay, so this one, when you see it on the worksheet, they'll have a big fraction bar, or a big radical that's on both of them, okay? Really, it means the same thing as separating the two of them and breaking them up individually. You don't have to rewrite it, and just making sure that you know it means the same thing. So the square root of 9 is 3, okay? And the square root of 64 is 8, and that's your answer, okay? So you're just taking the square root individually of those, because the square root is, like, it's big on the paper, and it's inside it. So nothing's really special on that one. Those are pretty easy that you should be able to just look at it, write your answer, as long as you know the perfect squares.
But are the fraction ones always going to have perfect squares?
I think so, from what I've noticed.
Okay.
Okay. The exercise is always the one that they throw weird things in there, and I don't know until you guys show it. Okay, so 67, we have a perfect square, which would be 2. Okay, and then what do we do with, that would just become an x, right? Because remember, it's an x and an x, so there's a pair, so it comes out, so there's none left. So this one's a perfect square. Okay, next one. And I tried to pick as an example of each type that you're practicing on your own. I think I got them all, but I got. Okay, now we don't have a perfect square this time. Okay, so 12. What do you want to break it down?
3 and 4.
3 and 4. Okay, 3 is prime, 4 is not, which would be 2 and 2. So that means I'm taking the pair out. So 2 is coming out. What number is staying inside?
3.
3. Okay, Now, remember, I don't want to have to go x, 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 and write out 9 of them. I can just divide this by 2. So 9 divided by 2 is 4 times, right? So I can bring 4 of them out, but there would be 1 left over. So basically, anytime you have an odd number, you're always going to have 1 left over inside. Okay, go ahead.
How do you get the 4 and the 1? So 9
So I divided, so 9 divided by 2 would be 9. It can go in there 4 times, right? So
Oh.
there's 4 of them,
Yeah.
but there would be 1 left over.
Okay.
And if not, you can go ahead and do this 1, 2, 3, 4, 5, 6, 7, 8, 9. And then you'd have a pair, you'd have a pair, you'd have a pair, you'd have a pair.
Okay.
That's just the walk route. There's nothing wrong with it. Okay. So now the next one, divide by 2, so that would mean 5 are coming out. Am I going to have any left over? No. You good? Okay. 51. Okay. So besides writing this, where we're referring to this one is back, is back here. When we're adding and subtracting, we can only add and subtract like terms. Okay, so keep that in mind. Radicals are like x's. Okay, the radicals have to be exactly the same in order for you to add and subtract the numbers in front. Okay. All right, this one's broken down. We can't break that one down, so that's simplified. But I've got to simplify this one. Okay, so I'm going to go back to you guys picking the 3 and 4. This would be 2 and 2. Okay, so this becomes 2 rad 3 minus rad 3. When variables are by themselves, we say there's a what in front of it? A 1. So same thing with the radical. When there's not a number in front of it, this is really a 1. Okay, I have like terms. My radicals are the same. I don't do anything with the radicals. I only add or subtract depending on what it is in the problems. The numbers that are in front. So this is really 2 minus 1, which is just going to be 1. So it's 1 rad 3, or you can just write it as rad 3, because anytime a radical is by itself, in front of it is a 1. Okay, so radicals are like x's. Adding and subtracting, you can only add and subtract if the radicals are the same. So sometimes they will be, sometimes they won't. Okay, so like the example we did where we had an x, y in one of them and just an x in the other one, then you can't combine them. Okay. Almost done. Okay, so individually I got to make sure my radicals are simplified so I know which ones I can add and subtract. So 8, I'm going to go 2 and 4 and 2 and 2. Okay, so I have a pair of 2's and it's coming out, but I already have something on the outside. What do you think I do with it? Multiply it. It's no different than when you're taking multiple things out. You multiply it. So this is 2 times a negative 2, so it's going to be a negative 4 rad what? 2, because there was a 2 left over that didn't have the 8. Okay, 12, 3 and 4, 2 and 2, 2 comes out, so I have a negative 2 rad 3. Do I need to simplify the next one? No, because 2's prime, you can't break that down any further, so it's already simplified. Okay, 75.
25 and 3.
Okay, so 3 and 25. 25 would break down into 5 and 5. I have a pair, and there's already a number out there, so that'll change to what? Negative 15. Okay, and then there's 3. Okay, so we're looking for like terms. Okay, so I have a rad 2 here. I'm looking for another rad 2. I don't do anything with the radical. I only add or subtract the number in front of it. So I have a negative 4 and negative 2, so that's making a negative. Good. Rad 2. where the radical stays the same. Okay, then I have a rad 3 here and a rad 3 here, which would give me a negative 17. Rad 3. And then from there, you can't combine them because the radicals are different. So that would just be your simplified answer. Good? Okay. Almost. I want you to try this. Good? I didn't mess up. Okay. Okay. When we multiply, we actually like put them together. Okay. So shortcut to that is just instead of actually writing 600 and putting them together under the radical, because we end up breaking it down anyways, is just put them together under the radical, because then that saves you time and having to go, well, this is 16 times 10. Okay, so just put them together under there, but knowing that when you're breaking this down, you're looking for pairs between those two numbers, okay, rather than putting it together and breaking it back apart. Okay, so then I can break down 10, which is 2 and 5. I can do 2 and 30, 6 and 5, 2 and 3. Okay, so I'd have a pair of 2s. I'd have a pair of 5s. And nothing else, right? So a 2 comes out and a 5 comes out. So that means I would have 10 on the outside. What is left underneath? 6, because there was a 2 and a 3 left over, so remember we multiplied those back together. So sometimes it is easier maybe to put this together because you could have gone 6 times 100 and then saw the 10 and 10 and then saw your pair, brought it out, and know the 6 is 2 and 3. It might have been easier that way, but some of them won't be that obvious. Okay, so you just know that you're going to put those two together and then break them down from there. Okay, versus put them together, break them down. It's already been broken down for you. Okay, similar but different, and then you're going to try one on your own, and we're done. Okay, so we're distributing, which means to multiply. So just like the last one, okay, you can put these together if you want to and make it 1,250 and then break it down, okay, which makes it a big number. Or just know that when you're timesing, right, we're really just putting these guys together and then they're already broken down, but I can break them down from there. They're smaller numbers to work with, okay? So 10, I can go 2 and 5. 25, I can go 5 and 25, and then 25 breaks down into 5 and 5. So I have a pair of 5s here, and I have a pair of 5s here. So a 5 comes out and 5 comes out, so there's 25 on the outside. What is left underneath? 2. Good so far? Okay, now we're doing the same thing, but now we're distributing to here. So I have rad 10 times rad 10, which is rad 100, or you could leave it like this, and hopefully notice that we're going to have a pair, right? If you don't, you go 2 and 5, 2 and 5, have a pair of 2s, have a pair of 5s, and 2 times 5, there'd be nothing left, okay? So this is a perfect square, which makes it just 10, right? This is clear there. So it comes out, and there's nothing left. Can I combine this with this? No. This is like having a 25x minus 10, and I ask you, can you combine those? And you can't, because they have to be like terms. Okay? So this is your So don't subtract 10 from 25 and make it 15 rad 2. Yes? It's on the outside, so it's just a negative of 1 that's on the outside, so I just... Good? Okay, so you are trying this one, and then we're done. Okay, the only one that makes this one a little bit different is that 9 that's out in the front, besides variable. So if by chance I had a number that was out here when I distribute, then it would be that number times 9, but it was a 1, right? So 1 times a negative 9 is going to keep it as a negative 9. Okay, and then you had a pair of 3s, so it came out, there's already a number there, so you multiply it, and then there wasn't an x, so it's left, and then these radicals are not the same, and obviously you couldn't combine x and 7 anyways. Good? Think we got this? Okay, so those notes that you just took are the ones that you're going to hand in tomorrow with the lesson quiz. Okay, so keep them separate. Please don't join them with today's assignment. So you're just going to pull up the rest of the notes because some of them are just look at, you know the purgatory, write the answer down, so we don't have for that. So, so you'll do it on your own sheet. It's open on the calendar. Okay. We'll grade the notes at the beginning of class tomorrow before the quiz lesson quiz.